So as we already discussed with the certificates, we generated set of certificates. Now let's move to the configuration part. So in this section, we will generate Kubernetes configuration files, also known as kubeconfigs, which enables Kubernetes clients to locate and authenticate to the Kubernetes API server. So Kubernetes API server is the, I would say, a primary component. It's a very important component inside the Kubernetes cluster. Almost all the components inside the Kubernetes cluster talk to Kubernetes API, and it's a single point of contact to distribute the message transaction between the different components within the Kubernetes cluster. So we have to, give or generate certain configuration files to authenticate different components. So these kubeconfig files belongs to various components like controller manager, kube proxy component, scheduler components, and the admin user component. Okay, so let's move forward. Let's generate these configuration files. So as we discussed earlier, we will be using two master nodes, that is two controller nodes, master 1 and master 2, and API. This Cube API component belongs to master node, so we have to execute um, the upcoming set of commands to both master 1 and master 2. And as we are running two different instances of API server, we have to, just to achieve the high availability, we have to create a load balancer. We do have a load balancer node in our Kubernetes cluster, which has a specific location, a specific IP address. So I'm just setting a variable which called load balancer to the load balancer node's IP. So what happens is I will assign this IP, this variable to the Cube API public address so that whatever the components trying to access or need to talk to API server, it will not directly go to that specific API node, master 1 or master 2. It will rather than go to load balancer, and from there load balancer will redirect that request to any of the API node, either master 1 or master 2. Okay, let's move forward. We have already set this variable. So now we have to generate a kube config file for kube proxy service. So this will be the command. And you will notice like we are using kubectl config set cluster Kubernetes. The hard way is the variable I am assigning because this will be my cluster name. And you will notice like all those certificate we have generated in our previous steps is being used, like CA cert, because this is our CA certificate, our own created CA. Just to be authenticate properly, we are using proxy certificate key, all those certificate which we generated in our previous steps we are using here. I'm just hitting enter. So it says cluster Kubernetes, the hardware name is set, user system kube proxy is set, context default created, switch to context default. So we got that file generated, and this is the command kubectl config use context default at last being used. So same thing we need to use for the next component, which is kube controller manager, and same set of certificates we will use, and this will be the commands. So this will be the commands to generate the kubeconfig file for controller manager. So let's do a quick ls. Okay, and we'll try to find the newly generated files. So you can see kubeproxy.kubeconfig file here is being generated, and the kube config file is also being generated. Cool. So let's move forward and generate the same kube config file for the next component, which is kube scheduler. Same set of commands. just the variable and the naming convention is different. So you can notice this is the command we are generating, and as an output we are getting kubescheduler.kubeconfig. Okay, so next let's generate the kubeconfig file for the admin user. So we have already generated for all the major components. Now let's generate it for admin user, which is the super user for this Kubernetes cluster. We got that file created. So now as we have all kubeconfig files generated, and the next step we will copying those files to the appropriate nodes. For example, the kubeproxy kubeconfig file, which is required by worker nodes, we have to copy them to all the available worker nodes. So in this demonstration, we have only two worker node, worker 1 and worker 2. So I'm using kubeproxy kubeconfig file to these two nodes. And for this, I'm using same for loop. So I'm using a for loop, transferring this file. The destination would be worker 1 and worker 2. And I'm sitting on the same directory where this file is being generated. And file is kubeproxy kubeconfig. And I'm transferring this file to these two nodes. I do have passwordless SSH enabled, so it should not ask for any credentials. And you can see the file is being copied for both of the nodes. That's why we have two different entries here. And we are back into our shell. Okay. And in the same manner, we have to copy admin.kubeconfig, kube controller manager kubeconfig, and kube scheduler kubeconfig files to the controller instances. So when we say controller instances, which means the master instances. So we have to use same for loop and provide the destinations instead of worker 1, worker 2. This time we have to use master 1, master 2, and just do a secure copy for these files to these destinations. So in this step, what we are doing is we are just transferring, or we are just copying these files to the appropriate nodes. Like few components are running in master nodes, so we are master specific configuration files or certificate files. We are transferring to master nodes, and same the required configuration files to run a worker node, we are transferring those to the worker nodes. So we are done with the configuration, sort of. And as we all know, like Kubernetes stores a variety of data into the Kubernetes cluster for application, like application specific configuration files and secrets, password, which has some sensitive data. So that just to overcome to any security risk, have an option in Kubernetes which supports the ability of encrypt these data. Okay, so for that we just need to add certain configuration. We have to specify one variable first, which is encryption hyphen key, and we will set it to the value of a wrandom, like this is mentioned in this command. So we just need to set this variable value. Okay, and we need to create a configuration file, YAML based configuration file for this encryption setup. We call it encryption-config.yaml, and just provide the basic structure that does not have any specific variables we have to specify. Just we are using the default template, I would say, and just providing the key name is key1, entering, because we are generating this configuration just for demonstration purposes. It's not a production cluster. Okay, so now we have generated this encryption config.yaml file, and the next step would be copy this file to the each controller instance. So again, when we talk about controller instance, it's master nodes. So we will use the same method we will be, as we have two masters, master 1 and master 2, just to transfer these files in one go, I will use a for loop and transfer this file to both of the destination, master 1 and master 2. That's it for this security perspective. And let's move forward for the next step, where we have to set up a ETCD component and bring it up. So remember that as we talked earlier, ETCD, we are in this demonstration, we are demonstrating co-located ETCD. That means ETCD will be running inside the master or the controller nodes. So as we have two controller nodes, we have to set up two instances of ETCD. That means in a ETCD cluster, we have two members. One will be running on master 1, one will be running in master 2. So for that, we have to execute all those subsequent commands in master 1 and master 2 both. So first thing will be just downloading the binaries from the official site, and we have to do it on both the nodes. So currently I'm sitting on master 1, so I just use this wget command to download the binaries. And I will hit the same command to the master 2, just downloading the binaries in this command in this step. So once these binaries got installed, we have to extract the binaries. So let's quickly just do a ls, and we can see we got those binaries. And next step, let's extract, as it's in archive format, you can see it's in .tar.gunzi format. So we just need to extract, and this will be the command for extracting. And just remember, we have to perform all these operations into both of the masters. So I'm executing the same commands in master 1 for extraction of that package. Okay, so now we do have binaries. We have extracted those binaries. Now we just need to create appropriate directories and move our certificates which we already generated for ETCD to those appropriate directories. So for that, we will use this command. We are creating a directory, etc varlib etcd and etcd hyphen etcd, and just copying csert etcd server.key etcd server.cert to etcd/etcd directory. And we have to do it on both of the nodes. Cool. So now we have transferred those files into appropriate directories. So next step will be setting up a variable, because we have to specify the internal variable which will be used to communicate between these two etcd instances internally as in cluster peers. So we just have to execute this command, and it will automatically picks up the internal IP assigned to your virtual machine and assigned to this variable. And as we have more than one etcd instance, and each etcd instance should have a different or unique name, so we have to, okay, I forgot to copy this command and execute in the master 1 as well, because this is also our etcd cluster member. Okay, and now we have to specify one more variable defining a unique name for this etcd instance which is running on master 1, and I'm assigning it to the value with the hostname value, and same will be for master 2. Cool. So now we have all the prerequisite done for ETCD. Now let's create the ETCD system D configuration file, because this ETCD service will be running as a system service, system D service, I would say. And for that, we will use the certificates which have been created, IP address. Like you can notice here, we are using the name which we have assigned to our variable in our previous tab. We are using ETCD certificate key pair, which we are generated to communicate with these instances. Okay, and trust store is our signing authority, CS certificate which we have generated. Internal IP, this port, we have already set this variable to fetch and assign this internal IP, and all this configuration where it will be listening, and the cluster master will be master is equal to this, and master 2 is, because we have two nodes master cluster, so we have to specify those IP address and port combination here, and just hit enter and it will create this systemd file. So now we have created a etcd service. So the next step will be, we just have to start that service, enable that service, so that every time your virtual machine restarts, that service automatically become active. So daemon reload is just to reload the configuration. Enable etcd will be enabled that etcd service, so that every time you restart your node, your service will be automatically be running. This etcd start command will be used to start that service at first place. So you can see that is been created. So if you wanted to see if that service actually exists now, so you can use the systemctl status etcd command, and we can see this is running. It is in active state, it is in enabled state, and we are good. And same steps we have to repeat into master 1, as we just assign the host name here. So as after assigning the host name, we need to create the system configuration file, systemd service configuration file, and create that service. So I will be using the same steps as we used for master 2 here, and just enabling, loading the configuration and enabling those services and starting that etcd service. So now we have two etcd services running. One is in master 1 and one is running in master 2. Systemctl status etcd, and we can ignore this value. We just have to bother about this active and enable state for now. So let's hit this command, which is the etcd command, etcdctl, just to fetch the member list, just to check the cluster status, etcd cluster status. Notice that we are not moved to Kubernetes cluster for now. For now, we just created a etcd cluster, and we are checking that etcd cluster health. And we can see there is a two instances available in this etcd cluster. One is running on master 1. This is the IP port combination they are listening for, they're working for, and these are the random IDs. So we are good. And if you execute the same command from master 2, it will give you the same output. There we go. So in the next step, we will move forward and install the master components. We will download the binaries from the dedicated sites and just run those as in systemd services as an individual component.